Everyone, welcome back to my last video on chemistry. Today we'll be doing redox reactions and we'll be going over three different types of balancing. And the first one is going to be balancing using oxidation numbers. So over here we have hydrogen sulfate with hydrogen iodide which reacts to produce hydrogen sulfide with a iodide ion and water. So going ahead and doing our oxidation numbers, we're going to do, the ones that we know. So we know that hydrogen is going to be positive 1. So sulfur we don't know, oxygen is negative 2. Halogen, so it's a negative 1, positive 1. Neutral for elements. Going back and doing this, doing math, 8 minus 2 is 6. This is negative 2. Okay, so now I'm going to see what ended up taking part in my reaction. I see that hydrogens, they're all the same, positive 1, so the charges didn't change, so it's fine. Sulfur, I see that it changed from a positive 6 to a negative 2, so that obviously went through a reaction. And iodide, negative to neutral. So there we go. Now I'm going to go ahead and really analyze these charges. I see that sulfur actually gained 8 electrons. So it reduced its charge by gaining 8 electrons per sulfur. And over here, iodide ended up oxidizing by lost 1 electron per iodide. And over here, if you notice that there are subscripts for iodide, we don't really need to worry about sulfur because really, what do you have? You have nothing. So it doesn't count. So if there is subscript, you're going to take that into account and you're going to go ahead and multiply it. So you're going to go ahead and multiply it by 2, giving you 2 electrons. And from there, what's that done? You have to try to make sure that the electrons on the top equal the electrons of the other reaction as well, so they're the same. So if this one gained 8 electrons, theoretically the other 4 electrons that you don't have should be gained. 6 electrons have to be taken in by something else. So if you're gaining 8 electrons, you have to lose 8 electrons. So at the bottom you're only losing 2. So I'm going to find the lowest common multiple, right? And let's say, and to make it equal to each other, it would end up being 4, right? And so that would give me also 8 electrons. So now this and this are equal to each other. That's what we want. So now when we're balancing in by adding the coefficients, we have to take into account the numbers that we've multiplied. So over here, if we're trying to do iodide, we see that both of these highlights do not correspond here, right? There's no 2 and there's no 4, so I'm going to multiply the 2 to give me 8. And I'm going to add my coefficient of 8. Over here on the other side for iodide, oh my gosh, there's 2 over here. And there is no 2 over here. There is already a 2, but there's no 4, so I'm going to go ahead and add a 4. And for sulfur, it's neutral, right? There's no highlights, there's nothing, so it's fine. And then if I go through, I'm going to go ahead and do grade 11 balancing to balance the rest of the molecules in the atoms. So I see that oxygen on this side has 4, whereas on this side it only has 1. So I'm going to balance that. And now if I've balanced oxygen, I've basically balanced the whole thing. On this side I have 10 hydrogens, this side I have 10 hydrogens, and 4 oxygens, and iodide and sulfur we already balanced from before. So now that's your balanced equation. But looking back, I'm also going to put into light that your reducing agent, which I'm going to circle, is actually your hydrogen iodide, right? And your oxidizing agent is hydrogen sulfate. Okay. Now going back and doing balancing using the ion-electron method for the reaction in an acidic solution. So here we go. So we have arsenic trioxide with a nitrate ion producing arsenic acid and dinitrogen trioxide. So I went ahead and put them into half reactions, right? This one has to potentially become this, and this one has to become this. So going ahead and putting into my half reactions, A and B, I'm going to go ahead and first balance my, these are not supposed to be there, balance my arsenics first. I see there's 2 here, so I'm going to put a 2 here to balance my arsenic, and I'm going to balance my nitrogen. There's 2 here, so I'm going to go ahead and balance it with a 2 over there. right? That's why there was a 2 from before on those in those places. So going ahead and doing that, now I'm not going to touch my hydrogens or oxygens because over here, if I look at my chart, that's what I'm going to use to balance my hydrogens and my oxygens. So I see that for every oxygen, I need to add a water molecule. So I'm going to do that. So I have over here 8 oxygens. Over here, I only have 3. So to balance it, I'm going to add 5 water molecules. And I'm going to do the bottom as well. The bottom, there's 6 here, and there's only 3 oxygens here. So I'm going to add 3 water molecules. And I'm going to do my hydrogens this time. So I've ended up adding 10 hydrogens right over here. And I have 6 over here. So I'm going to add 4 hydrogen ions to balance it off. And over here I have 6. So I'm going to add 6 hydrogen ions. Okay, and with that, I've balanced my hydrogens and my oxygens, but I have to do my charges now. So looking at my charges, I see that over here it's overall neutral. Over here I ended up with 4, so positive 4, and positive 6 minus 2 is going to give me positive 4. And over here, again, it's neutral. So it says charges are added to the more positive side. So that's what I'm going to do. Over here, I'm going to add 4 electrons. And on this side, it's more positive here than a neutral, obviously. So I'm going to add 4 electrons. And looking ahead, I see that to get to my therefore statement, I have to add my A and B, my 2 half reactions. So I see that over here, this and this will cancel. One's on the product, one's on the reactants. Therefore, they will cancel. Over here, 3 water molecules, 5 water molecules. So I just have 2 water molecules. Here, there's 4, there's 6. That becomes a 2. Now, that makes life easier. So now I'm going to add it. So I end up with this plus my 2 water molecules plus my 2 nitrate ions reacting to give me my 2 molecules and my dinitrogen trioxide. And that's how you balance this equation. There we go. So now we're going to go on and we're going to do our last equation, which is going to be balancing using the ion electron method for a reaction in a basic solution. So for this, we have nitrogen dioxide with a nitrate ion and a nitrite ion. So I wrote my nitrogen dioxide twice because in a solution you have multiple nitrogen dioxide ions and you have multiple nitrates and nitrites. So it only makes sense that you have a nitrate that can either make a nitrite ion or a nitrite ion, right? So that's what is happening. That's why I wrote it twice. So over here, I'm going to go ahead and try to do grade 11 balancing, taking a step back and looking at my nitrogens. And I see, okay, they're already balanced, so I'm not going to bother. And now I'm going to balance my oxygens and hydrogens, but I have to use my chart over here to do so. So looking at my chart for every oxygen, it seems that now it's different. I have to add 2 hydroxide ions, and if I add 2 hydroxide ions to one side of the equation, I have to add 1 water molecule to the other side. So it ends up with a 2-to-1 ratio. And for hydrogen, for every 1 hydrogen I need, I have to add 1 water molecule, and to the other side, 1 hydroxide molecule. And charges are the same as the one before. So going ahead, balancing off my oxygens, I see that I need 1 oxygen on my reactant side. So I'm going to go ahead and add my 2 hydroxide ions because of the 2-to-1 ratio. And if I add 2 here, I have to add 1 water molecule on this side automatically. So when I do this, I automatically balance my hydrogens as well. So I don't need to do my hydrogens to balance off the green like I did above. And for here, my oxygens are already balanced, so that's okay. And now if I want to look at hydrogens, there's no hydrogens here, none. So I'm not going to bother. Go ahead and go into charges. So charges, this one has a -2, -1, -1, neutral charge. So over here, I'm going to add it to the more positive side. I'm going to add 1 electron. To the more positive side, I'm going to add 1 electron. And I see that they're both equal to each other. Oh, there we go. So I'm going to cancel them out. And there we go. That's about it because I can't really cancel anything else out. So I'm going to go ahead and add. I'm going to add these 2 together, right, as I should. So it ends up being 2 when I end up adding the 2 half reactions, plus my 2 hydroxide ions. And there's nothing else on this side. For this side, my nitrate ion plus my 1 water molecule plus my nitrite ion. And that is how you balance in a basic solution. Thank you, and I hope you've enjoyed and learned something new today. Take care.